Okay, so in this video, we're going to convert the decimals into fractions. So far, you've only been looking at the notation and converting from fractions to decimals. Well, this is the other way around. There's a couple of things that you need to notice when you're doing this. Number one, you'll notice that it's asking you to prove something algebraically, and that's typically the method we're going to use for this. And number two, it actually tells you what the conversion is. So it's not just saying convert 0.3 recurring into a fractions, it's asking you to show what it is. So you actually have the answer of the conversion given to you. You just need to show how do we get from one to the other. So the first thing you want to do when you're converting using the algebraic method is just let any letter, here I'm just going to pick x, equal to the decimal. So we're going to say x equals 0.3333 recurring. And then after that, we're going to work out what 10x is. And I'm going to write 10x on top for reasons is going to become apparent in a second. So 10x equals, well, 0.3 recurring times 10 is just going to be 3.3 recurring. And that will go on forever. We're then going to do a subtraction. So we can see from the subtraction 10x take away, well, this is actually 1x here. So 10x take away 1x is 9x equals, now for this subtraction, 3 take away 0 is just 3. The recurring part though, after the decimal matches in both cases, it's just 3, that goes on forever. So we can just say that that's just cancelled, it cancels out. And we don't need to write 0.000, it's just 9x equals 3. So if 9x equals 3, we can then divide by 9, and that will give us x equals 3 over 9, which simplifies to 1/3. Now there's two things we've done here. When we started off our question, we decided that 1x is equal to 0.3 recurring, but we've also discovered 1x is equal to 1/3. Therefore, 0.3 recurring is equal to 1/3. So using the same method, have a go with the question on the right, and then I'm going to go through it in a second. So you need to pause the video. Okay, so hopefully you've done the question on the right using this method, showing a clear working out, and now I'm going to go through it with you. So this time I'm just going to use the letter y. Doesn't really matter which letter I choose. So y equals 0.5 recurring and 10y equals 5.5 recurring. So you can see the logic here. We're trying to make sure that the thing after the decimal matches up. So when we subtract it, it cancels out. So 10y take away 1y is 9y, 5 take away 0 is 5, and then the recurring part cancels out. So then we have from here, divide by 9, so y equals 5 over 9. And that is your proof that 0.5 recurring is equal to 5 over 9. Okay, so your turn to try with this 0.6 recurring. Have a go. Okay, so pause the video if you haven't done it. I'm going to go through it now. So the first thing we want to do is pick a letter. So I'm just use z is equal to 0.6 recurring. So we can say let z equals 0.6 recurring. 10z is going to equal 6.6 recurring. And then we can do the subtraction. So 10z take away 1z is 9z equals 6. The recurring part cancels out. So then I have z equals 6 over 9 because I've divided by 9 on both sides. 6 over 9 simplifies If you divide it by 3, it's going to be 2/3. And so 2/3 equals 0.6 recurring. And that's your proof. So you may have also spotted a few interesting patterns here in terms of the fact that when you have a single digit recurring after the decimal place, you're going to get that digit over 9. So there are some other more interesting patterns as well, especially when the digits repeat in different combinations. But this is just an interesting look at the first basic type of recurring decimals. So in the next video, we'll look at what happens when you have different patterns.